this is Lemuel again, and today's video is about performing mensuration and calculation.
Our first topic is about types of components and objects to be measured. Do you have any knowledge about computer components? Because today, we were talking about the definition of it. All the different pieces of electric hardware that join together to make up the complete computer system is called computer components. The example of common computer hardware components: motherboard, CPU, RAM, BIOS or ROM, graphics card, peripherals, storage device. Features of internal hardware computer components. Internal computer components are designed to fit inside the computer system, and they all carry out important roles. We will discuss the following. Motherboard. This does something with the data to make it useful information. Processor. The central processing unit. Internal memory. RAM and ROM. Video card, aka graphics card. Sound card. Internal hard disk drive. Internal memory or RAM and ROM. There are two types of internal memory, the RAM and the ROM. RAM and ROM are used to store computer data, and this can be directly accessed by the CPU. RAM and ROM are sometimes referred to as primary storage. RAM, Random Access Memory. RAM is used to temporarily store information that is currently in use by the computer. This can include anything from Word documents to videos. RAM can be read from and written to, and so the information stored in RAM can change all the time. It depends what task you are using the computer for. RAM is the fast memory. Data can be written to and read from RAM very quickly. RAM is generally measured in gigs or gigabytes. RAM is volatile memory. This means that information stored in RAM is deleted as soon as the computer is turned off. This picture is an example of RAM. From the monitor, the unsaved document currently stored in RAM. Then computer loses power off because it was suddenly switched off. Then after that, contents of RAM deleted and document is gone. Remember, RAM is volatile and stores data not permanently. RAM's contents are deleted as soon as the computer loses power. This is why you lose unsaved work if there is power cut. If you want to keep your work even when the computer loses power, you must save it to a permanent storage device like a hard disk drive. The more RAM you have installed in your computer, the faster it can perform. You can open and use more programs at the same time without slowing the computer down. Read-only memory, or shall we say ROM. ROM is used to permanently store instructions that tell the computer how to boot or start up. It also loads to operating system. These instructions are also known as BIOS, or Basic Input-Output System, or the boot program. Information stored in ROM is also known as read-only. This means that the content of ROM cannot be altered or added by the user. ROM is fast memory. Data stored in ROM can be accessed and read very quickly. ROM is not a volatile memory. This means that stored information is not lost when the computer loses power. Another example of ROM include DVD, CD-ROMs, both in stores containing pre-recorded music and movie files. These are played back at home but cannot be altered. ROM in printers, which is used to store different font types. How to remember the difference between RAM and ROM. In RAM, Contents are lost when the computer is turned off. In RAM, stores data programs currently in use. In RAM, your computer will perform faster with more of this. With RAM stands for Random Access Memories. How to identify or to remember the room. The room is contents are not lost when the computer is turned off. Number 3 stores instructions that tell the computer how to start up. Number 4 stands for Random Access Memories. And 5, this cannot be written to alter or only read. And number 7 is stand for read-only memory. Next topic is the video card, aka the graphics card. Graphics cards are hardware devices that plug into the motherboard and enables the computer to display images in the monitor. Graphics cards usually require the installation of software alongside the hardware. The software instructs the computer how to use the graphics card and also allows you to alter settings to change image quality and size. See below for an example of graphics and software allowing the user to alter various graphical settings. The next topic is about storage devices or secondary backing storage. Secondary storage devices are used to store data that is not instantly needed by the computer. Secondary storage devices permanently store data and program for as long as we need. These devices are also used to back up data in case original copies are lost or damaged. Remember, temporary storage like RAM does not hold data for long periods. It is used to store only those programs and files that we are currently working on. There are two categories of storage devices. First, the internal storage or the internal hard disk drives. Second, the external storage or the external hard disk drive. The next topic is about processor or the CPU, Central Processing Unit. The Central Processing Unit or the CPU is the brain of the computer. The CPU controls what the computer does and it's responsible for performing calculation and data processing. It also handles the movement of data to and from system memory. CPUs come in a variety of speeds which are known as clock rates. Clock rates are measured in hertz. Generally, the faster the clock rate, the faster the performance of the computer. There are two main brands of CPU currently in the market, the AMD and the Intel. And now, let's talk about the types of measuring instruments and their uses. Number 1, a meter rule is a device which is used to measure lengths of different objects. Number 2, Vernier caliper, used for measuring smaller distances such as diameter of rod, internal diameter of a tube, and a thickness of a plate. Number 3, micrometer screw gauge, used for measuring extremely short lengths such as the diameter of wire and thickness of paper. Number 4, measuring cylinder, for measuring volumes of liquids. Number 5, stop clocks and watches, used for measuring time. And number 6 is the spring balance, used for measuring width. Number 7 is thermometer, used for measuring temperature. Next is hydrometer, used for measuring density of liquids. Next is voltmeter, used for measuring electric potential voltage. Next is ammeter, used for measuring electric current. Next is photometer, used for measuring luminous intensity. Next is a nereid barometer, used for measuring atmospheric pressure. Next is the anemometer, used for measuring speed of wind. And now let's talk about safe handling procedures in using measuring instrument. Measuring tools, by their very nature, are meant to be perfectly precise, and to keep them that way, they will have to be cared for and maintained properly. There are a lot of different tools for measuring a lot of different things, but no matter which one you have, proper care is required if you want to be able to depend on them for accuracy. Caring for your measuring implements will mean that they will serve you well, often for a lifetime. Not caring for them means you have to replace them far sooner than you would have if you had taken the time to provide the right sort of maintenance. Here are some tips on how to care for your measuring tools. Always use your tools used for measuring for that alone measuring. This means don't use your micrometers for little hammers or a vernier caliper as a line marker, for instance. This will certainly damage them. Always keep your tools used for measuring at or around room temperature. Never lay them on a heat source or in a direct sunlight, as doing so could really mess them up so that their accuracy is affected. Always clean your tools after use, unless they're made of stainless steel. Each tool should have some anti-rust oil dabbed on it and then stored by itself in a dry place. Always wipe not only the measuring phases of your tools, but of the workpiece being measured as well. This will help you prevent dust or dirt from marring your tools. Generally speaking, it is best not to use such tools as vernier calipers or micrometers on rough, abrasive surfaces if you can possibly avoid it.
And now let's move on to the next topic. It's all about the 4 fundamental operations in mathematics.
First, the addition. Adding plus adding equals to sum. For example, 73 is the adding, plus another adding is the 45, equals to the sum of 118.
Next is about multiplication. For example, multiplicand times multiplier is equals to product. 7 times 4, it is equals to 8. 28.
Next is about division. Dividing divide to divisor is equals to quotient. For example, 64 divided by 8 is equals to 8. That's correct. Next to subtraction. Menuing subtract to subtrahend is equals to difference. For example, 67 subtrahend to 14 is equals to how much? 53. That is okay. Hello guys, this is our next topic. Is about the formula of perimeter, area, and the volume. Let's talk about the perimeter first. The perimeter of a polygon or any other closed curve such as circle is the distance around the outside. Number 2, the area of a simple closed planar curve is the amount of the space inside. Number 3, the volume of a solid 3D shape is the amount of space displaced by it. Some formulas for common 2-dimensional plane figures and 3-dimensional solids are given below. The answer have 1, 2, or 3 dimensions. Perimeter is measured in linear units, area is measured in square units, and volume is measured in cubic units. This is the table 1. Perimeter formulas. In shape, for example, the shape is square, so the formula is P equals to 4S. S is the length of the side of the square. If the shape is rectangle, the formula is P is equals to 2L plus 2W. L and W are the lengths of the rectangle sides, length and the width. If the shape is triangle, the formula is A plus B plus C. And A, B, and C are the side lengths. If the formula is right triangle with legs A and B, the formula is P is equals to A plus B plus A squared to the A plus B squared. A and B are the lengths of the two legs of the triangle. When the shape is circle, the formula is P is equals to C equals to 2 pi r and pi v. R is the radius and D is the diameter. Let us go to table 2, the areas formulas. When the shape is square, the formula of the area is A is equals to S squared. S is the length of the side of the square. When the shape is rectangle, the formula is A is equals to LW. L and W are the lengths and the rectangle sides, length and width. When the shape is triangle, the formula is 8 equals to 1/2 BH. B and H are the base and the height. When we say the shape is triangle, the formula is A is equals to square root of S open parenthesis S negative A close parenthesis S negative B close parenthesis open parenthesis and S to negative C and close parenthesis. As you can see in the table, this is the formula. A and B and C are the side lengths and S is the perimeter. Parallelogram, if the shape is the parallelogram, the formula is 8 equals to BH. B is the length of the base and H is the height. When the shape is trapezoid, the formula is A is equals to B to the exponent of 1 plus B to the lower exponent of 2 over 2. Then H is the side. B1 and B2 are the lengths of the parallel sides and H is the distance or height between the parallels. When the shape is circle, the formula is A is equals to pi r squared and the r is the radius. And the table 3 is the volume formulas. As you can see here, if the shape is cube, then the formula is B is equals to S cube. And the variable S is the length of the side. So, right, rectangle present, the formula is B is equals to L and WH. And L is the length, while W is the width, and the H is the height. followed by the other shape here, as you can see. And that's all. Let's proceed to the next topic. Hello guys, this is our next topic about the measurement, conversation, and formulas. As you can see in this video, there are lots of different formulas. And the first one is about the area calculations and its shape. For example, the circle. As you can see, the formulas of the circle is area is equals to pi times r squared, or the pi is equals to 3.14. And the following others is here, as you can see. And this is a very important formulas. Okay, let's tackle about the percentage mixing. To determine the amount of pesticide needed to make a solution or suspension containing a certain percentage of active ingredient, use one of the following formulas. So this is the formulas on how to calculate the amount of pesticides needed to make a solution and how to calculate for that. And the following formulas here, the common conversion factors. If you want to know more about this topic, you can you can search it to the Google. Just put it to your search engine, the pesticide, the measurement conversion formulas. Okay, that's all guys, and let's proceed to the next topic. Hello guys, this is our next topic. It is about memory units of computer: bit, byte, KB, MB, and gig. This is the example for that. 1 KB is equivalent to 1024 bytes. 1 MB is equivalent to 1024 KB. 1 gig is equivalent to 1024 MB. 1 TB is equivalent to 1024 gig. 1 PB is equivalent to 1024 TB. So, do you have any knowledge about memory unit? So, what is memory unit? According to definition, a memory unit refers to the amount of memory or storage that is used to measure or represent data. And this is the basic memory units in computer. The first one is the binary digit. A computer system uses electrical components to handle data or information stored in it. The second is the nibble. Nibble is the collection of 4 bits. And then the byte is a collection of 8-bit sequence together to create a single computer alphabetical or numerical character. A byte is referred to a fundamental unit of measurement for the data of computer system. The word, like a byte, a computer word is also a combination of fixed number of bits. Is another basic memory unit of computer system, and the number of bits in a word may vary for each computer system. However, it remains fixed for a particular computer. Notes here. Bits and bytes are known as the basic building blocks of memory, where the bit is the smallest memory unit of a computer that is used to express data size. Additionally, a byte is a smallest unit that is used to represent data items or characters into higher memory units. Okay guys, I think that's all for today, and let's proceed again to the next topic.
This topic is all about maintenance of measuring instrument. Maintenance of measuring instrument. The world's best measuring instruments are all but worthless if they can't be relied on to provide accurate, reliable results. micrometers, calipers, dial gauges. Lubrication of measuring instruments. Proper lubrication of measuring instruments will prevent damage due to corrosion, oxidation. Precision measuring instruments should be lightly oiled after each use, and any excess oil should be removed from metal surfaces with a clean dry cloth. A visibly wet instrument can attract and hold minute particles that can cause internal wear of precisely fabricated parts, especially those that move against one another. Lubrication of measuring instruments. In addition, do not use penetrating oils or other compounds designed for purposes other than light lubrication. For example, avoid spraying your instrument with, as it may leave a film that can alter the calibration of the instrument. Even the tiniest layer of foreign substance can throw off the accuracy of some measuring instruments, such as calipers and micrometers. Storage of measuring instruments. Whenever you place an instrument in its storage location, be sure the location is well protected from distracted elements. Do not store precision instruments where they can jostle against one another in a drawer. Instead, separate instruments from one another using dividers or place them into the padded cases. Avoid stacking instruments on top of each other unless they are well protected in cases.
And that's all for today. See you on my next vlog. Bye-bye.